All right, in 5.6b, we are continuing with the standard normal distribution, and we're going to find areas underneath the curve without using the empirical rule that we used in 5.6a. So, all normal standard distributions are the same if we measure in units the size of sigma, which is the standard deviation from the mean, mu, as the center. So we measure in standard deviations. Okay, how many standard deviations from the mean is it? So here's the normal curve. The mean is the middle, right here, 0. And then if we move to the right 1 standard deviation, then that has a value of 1, a z-value of 1, meaning 1 standard deviation from the mean, 2 and 3. And then if you go to the left, it would be -1, -2, -3. So if a variable x is a normal distribution with a mean mu and a standard deviation of sigma, then the standardized variable, the way we know how many standard deviations away it is we use this formula, which we've used this before, way back like in chapter 1 or 2, where x is the observed value, mu is the mean of the situation, and then you subtract, then divide by the standard deviation. And we're not going to be using the z formula today, we're just going to be finding areas under the curve using mu as 0 and sigma as 1. All right, so here's one type of problem. It's an area problem. And it says, suppose we want to find the proportion of observations from the standard normal distribution that are less than 0.8. Okay, so the first thing I would tell you to do is draw a picture. Here's your standard curve. Done to be perfect, but the center is always 0. All right, so it's asking us, what's the probability that the z-score is less than 0.81? So what you need to do on every problem is draw a standard normal curve, put in mu as 0, and then look at this. Look at the z-score they gave you. This z-score is 0.81. That means it's not quite 1 standard deviation above. So if this is 1 standard deviation, and this is 2, and this is 3, then 0.81 falls like right here. It's close to it, but it's not quite. And it's asking for everything less than that. So I want all this area down here. Okay? Now, if we were using empirical rule, it wouldn't quite work because we don't have a solid 1 standard deviation that we're looking at. It's not quite 1, it's 0.81. Okay? So I need a calculator to figure this out. There are tables we can use in stats to figure this out, but the calculator is much easier. So that's what I'm going to show you. So here's the keystrokes. You need to pause the video and write these down. So I'm going to go second and vars. And then I want normal CDF. Make sure you don't need number 1. That's different. I want number 2, normal CDF. And then it asks you for these values. A lower, an upper, a mu, and a standard deviation. So let's look at your graph for a moment. Look at this. What's the lower end of this graph? What's the lowest x or z value down here? Well, it could go on, it goes on to nothing, right? Like all the way over here. So what we say in this situation is 1e to the 99th power. And that is default in your calculator. If you look at it, it's already in there, -1e99. So I'm going to the negative direction. All right. Now the upper bound is this 0.81 right here, a z-value of 0.81. And then the mu, if you see the default in the calculator, the mu is already 0. And when we're using z-scores, and today it's going to be 0, and your standard deviation is always 1, and that is the default setting in your calculator. So once you've filled in all those values, you scroll down to paste and hit enter. And it will give you the area. So the way that you would write your answer, you write your answer like this with the probability notation. Probability that z is less than 0.81 equals 0.791. And there it is. At least 3 decimals. You can take it to 4, but 3 is essential. Number 2 is an area problem as well. Suppose we want to find the proportion of observations from the standard normal distribution that are more than -2.3. That means our z-score is -2.3, and we want everything greater than that. So think about your normal curve, draw it out. Here's 0. -2.3 means I go to the left. 1, 2, And then here's my landmark spot, right? Negative 2.3 is like right here. Now, it's asking for more than. So I want to make sure that I visualize what's going on. That's why you graph it. That's why you shade it. Okay, so I shade to the left this time. Now, as far as boundaries, this is our lower bound is negative 2.3. If you think of this as a number line, this is going to negative, this is going to positive. So down here, our upper bound would be 1e to the 99. Okay, so you do second, vars, normal CDF, which is number 2. Lower bound is negative 2.3. Upper is 1e to the 99. Mu, since we're talking z-scores, mu is still 0. Standard deviation is 1. So let's enter that in our calculator. So my area is like 0.9892 or 9893. So the probability that my z-score is greater than or equal to 2.3, 0.9893. And that's how you would write your answer. Right? Last type of problem here. Let's find the 90th percentile of a standard normal distribution. We're looking for the z-score that has 90% of the area to its left. Okay, so here's the curve. It's already shaded for you. But if you don't know why it's shaded quite like this, think of it this way. Remember, 0 is right in the middle. So 50% on this side, 50% on this side, right? Well, 90 is greater than 50, so we shade it over here. And we know that all this area over here is 0.90. So if you realize that this area, the shaded area, is 0.9 or 90% of the whole curve, we need to know, okay, what is the z-score right here? We need to know what is that. That is our goal. So our notation looks a little different. Probability that z is less than something, this is our unknown, equals 0.9. So we have a function on our calculator that does that for us. So we hit second, vars, and it's called inverse norm. So you see it there. Inverse norm is number 3. Okay? When you hit it, it has a different menu. It'll ask you for what's the area. What's the area we're looking for? In this problem, it's 90.90. Okay? Mu, since we're using z right now, we would use mu of 0 and a standard deviation of 1. Those two things will not change today. Okay? Hit paste, enter, and bam, there's the z-score that splits that area. Makes 90% of it to the left, and then makes 10% to the right. So the way I write my answer, it's 1.282. So I would say the z would equal 1.282. That's the z-score I'm looking for. All right, so you will see some percentile problems. It helps greatly, so I want you to really draw these pictures and put down the percentile. So we know 90% here, we know 10% on this side, but when you do inverse norm, the calculator only takes in the area to the left. Okay, only takes in the area of the left. So if they give you a percentile, that's always area to the left, so keep that in mind. So in this case, it's asking me what's the z-score. It gave me the area, it wants the z-score. The previous problems gave us the z-score but wanted the area. So they're just reverses of one another. Okay, we'll see you in class.